What's up, everybody? Tonight we're going to be working on a little fix-it project. I just picked this Porta-power up secondhand. Pretty much everything I have in my shop I've bought secondhand. It's basically built my business. I picked this up from a guy in Salt Lake. This brand, the Power Team brand, is awesome. Second to none. This brand and Enerpac are probably the two best brands out there. So when this came on, I offered the guy, I paid him $350 for it. And brand new, this unit probably goes for $1,100. So I was pretty excited. It's in really good shape. It's got a gauge on it. The fittings are all here. It's ready to hook a hose on and a ram, and then you're rolling. Well, whenever you buy something secondhand, make sure you look it over, because I didn't look it over good enough. Because when I got home, I set it on the table and was just screwing around with it, and I noticed that's not stroke, that's slop. So from here to here, it's not doing anything. It's just flopping around. So that's pretty fantastic. So tonight we're gonna fix it. So what they've done, after I realized what was going on here, somebody decided to fix it, and they've got two bolts here on the front of this, and you can see they just put an extra long bolt in it, they cut it off, and then and I hate it when people do this, but they smacked it with like a center punch or something to keep it from coming out. So it's just a bolt. But the problem is the bolt it's not even the right size. Can you see how they're flopping around? And then, oh, it gets better. Ladies and gentlemen, it gets better. If you look in here, they've taken a nut and welded it on perpendicular right here. That's another reason that it's so sloppy. So anyway, tonight I'll probably buy the pins that actually fit the hole, and then there's usually a cotter key that goes through here. So I'll probably buy those two pins from the hardware store, and then we'll machine a bushing that goes here, and we'll TIG weld it on here, and there shouldn't be any slop once we're done. So the good news is these holes are still in really good shape. They're not worn out at all. They haven't been wallered out, so we're going to be able to get a pin that fits in there pretty snug. If we can't get a pin that fits tight in here, we'll just machine our own, because I want it to be tight. You want to be able to get as much stroke out of this as you can. And so they basically cut this Porta-power down to using only about 50% of its capability. Okay, so if you can see that, they just took and welded that nut onto there. That's a fantastic looking weld too. I really hope the people I bought it from didn't do it, because they were supposedly into some sort of a machining side hustle. Anyway, let's go ahead and cut that off and get it all prepped up to fix it the right way. Okay, this is a pretty delicate operation, because we don't want to scar the ram any more than has already been done. So we're just going to be really careful to just surgically remove that nut. Okay, so we got our nut cut off. You can see there's still some cleanup to do. So we're going to go ahead and buff that off and see how clean we can get it. I think we can get it back to where it looked close to factory, and then we'll go from there. Okay, as you can see, that's as far as we had to go to get to the factory finish there. But to get there was a little bit of weld and spatter, and the weld kind of bled over the edge here. I think that looks pretty good for what we had to work with. And if you push the piston all the way in, I'll have to get a tool to do it, but if you push it all the way in, we're still further down than this line, so I think we're good. Okay, so here's the measurements that I took. I measured these two holes on the handle. They're exactly the same, as well as this hole, and it's exactly the same. And when I say exactly the same, I mean the diameter is exactly the same. So, which is a good thing. We know there's not a lot of wear. I really don't think they use this Porta-power a whole lot. I'm assuming that somebody just dropped it and broke whatever was on the end of the ram here, and so that was their little fix. So we're going to go ahead and fix it right. Now what we want to do is we want to go over to the lathe and start machining our pins and our bushing. Now we want the pins to be about 1/1000th less than our bushing ID, just to give us enough room we want it to slide just a little bit and not have a lot of friction, but we don't want it to be sloppy either, because slop tends to cause wear. So we'll go over to the lathe and get set up and get turning these pins. Okay, so we got to get the right tool set up here. We got our all thread in the chuck, so we're going to swap these tools out. Okay, so this first pass we just want to knock the threads off. Okay, so we touch off. We're going to go about 25 thou on this one. Start our feed. Pass number 2. Pass number 3. We're not quite there. I guess I was wrong. Maybe it'll be 4. Now there's pass number 4. You can see we're pretty much at the bottom of the threads. I might take a little cleanup pass after that one, but it's looking pretty good. Okay, so I'm going to switch tools here. I think this other tool will probably give us a better finished pass. Okay, so for what we're doing, it's looking pretty good. I was going to machine the whole length down to the OD of what the widest part was, where the collar is, but I think instead what I'm going to do is I'll just machine one pin right now and not center drill it and use the live center. I'm just going to leave it sticking out the way it is and machine it right there. Okay, so I took my measurement here, and it looks like we are 638 thousandths. We're about 200 thousandths away from where our final pin diameter needs to be, which means we'll have a 200 thousandth shoulder, that's perfect. That's about what I was hoping for. So making our first shoulder pass. And we're going to go back. On the next one. Okay. I know you can't see it in a lot of detail, but we're right on the money. 438 thousandths. That's right where I wanted to be. So, the more I thought about this, the more I thought, if you're going to be a bear, be a grizzly. So, what I'm going to do is I'm going to machine a groove in the end of this, like right up against the outside of the handle. And I think I'm going to put a snap ring on. It'll just look more professional. I won't have to worry about the pin falling out or drilling a hole. So I think it'll be a cleaner fit. It'll look better. And what the heck, we're already here. It's funny, I actually bought these a long time ago. All these kits, snap rings and hairpins and, you know, all kinds of stuff, roll pins, and I've just had them sitting there because you never know when they're going to come in handy. What we've got here is we've got a whole assortment of snap rings, so we should be able to find just the right size that we need, and I think it's going to turn out. Okay, so this is where the old school art of machining comes in. I've got a piece of tool steel here. It's a cobalt high-speed steel mix, but it's tool steel for the lathe. Back before they had carbide tooling, this is what they used, and you actually have to grind your own profile into the end of that. So that's what I'm going to do, because I don't have a tool that is thin enough to cut me that groove. I've got to make my own. So here goes nothing. So I went ahead and ground that down and just gave it that profile. You can see you gotta taper it so that it's not dragging on the steel that you're trying to machine. I sanded it down on the belt sander, and so now we're gonna give it a try and see how it does. So we're just getting ready to cut our groove there. You can see that. What you want to do is you want to slow your lathe down really slow and use lots of oil, and then just take it nice and easy. Especially with a tool this small. And they suck to have to grind, so you're better off just taking your time. You can see that little groove. Now we're going to test it with our snap ring. Okay, I don't know if you guys can see that very well, but I've got the groove machined in for the snap ring. I've tapered the end, more for aesthetics than anything. And then I've got a mark right here. I've scribed my mark with my calipers right here, and I'm getting ready to part this off. And then I'm going to flip it around and I'll chamfer the corners so they're nice and smooth, and then that pin's done. So I just got to repeat this process, the exact same thing one more time, and then those pins are done, and then we're on to the bushing. Pin number 2 is in the works. Okay, so that's our number 2 pin. You can see we've got our snap ring groove machined in. We've got the end chamfered, and we're just getting ready to part it off, and then we're going to flip it around and we'll chamfer the other end, and then the pins will be done. Okay, so pins are done. Found a chunk of 316 stainless that we can use for our bushing. I'm just going to cut a little piece off the end of it. I'm going to run just a cleanup pass on it, and the OD will just be what it is. The ID will have to machine to the OD of what the pin size is, I wanted to make sure that the OD was big enough that it would be strong enough. But as you can see here, that's our old bushing. The new one, if you look, is going to be a lot bigger than even the fancy little bushing they used. So we're just going to roll with it. So we'll go back over to the lathe, we'll get this turned down, then we should be ready to take this back onto the ram, and that should be a task in itself. Okay, now we've got our drill chuck put in the tailstock. We've got a center drill put in. We're going to center drill a hole so that we can run a drill bit through it for our pin, which is going to slide through our bushing. There's our center drilled bushing, so now we're ready to drill our hole. Okay, we got a drill bit in. We're going to cut us a hole. We might slow that down a little bit more. We're going to see how it cuts. Slow it down a little. It's running just a hair fast. That's better. See how it's not squeaking? Nice smooth chips. That's what you want. So I'm keeping track of how deep I'm going by this gauge right here. Our bushing's going to be 1 inch wide, so I'll know by watching that gauge once we've reached that depth. Okay, so we used our memory cloth, ran it in and out of the hole, and it's looking pretty good. We got the pin to slide in, and it's nice and tight. There's like zero slop, so that's what we were hoping for. It slides in and out pretty good. The less movement we have, the more stroke we get out of the Porta-power, so that's what we were going for. So, all right, it's time to weld in the bushing. Okay, so we got this assembled roughly, but I was wondering if I could possibly tack it like this, but it doesn't look like I can. So we're gonna have to take this back off, and I'm gonna have to think of a better way to tack that where everything will be lined up. This could be tricky. Okay, there's been a discovery made. So with the Porta-power assembled, and I hope you guys can see this, with it assembled, if I swing this up, as I swing that up, this has an arc to it. So obviously it's not going straight up and down. That presents a problem, because if I weld that on there, that bushing, it's gonna bind up when I get to about here, because it needs room to float. So that being said, I guess I need to somewhat apologize for this menagerie, but I still would not have taken this road. But we're still gonna fix it, but we're gonna fix it my way. If I've got my bushing, okay, there's my bushing. Right now I've got a round hole. Okay, if I take and put it in the mill, and I mill it out this way and this way, just a hair, I'm going to try to measure how much movement it needs. That way, when I pull up on the handle, it's not going to move this way. But as you swing the handle up, because this free floats, it'll be able to travel left and right. Or at least that's what I'm hoping for. So, now I got to take it back apart, pull the bushing out. I'm going to put it in the mill, and I'm going to try to oblong this hole so that it's more of a slot. So, let's give that a try. Hopefully you can see that. It's giving us a nice oblong hole. And now I gotta flip it because my end mill is not long enough to make it all the way through the bottom. So I gotta flip it and do the same thing. But before I take it out of the vise, I'm gonna mark it so that I know how to clock it when I put it back in the vise. Okay, so you should be able to see my mark there. I just got a Sharpie mark. So I marked it just like that, and then I pulled it out, and I transferred the marks down the sides to the other side. I've got it flipped over now, and I'm ready to mill the other side. Okay, so we've got our bushing done. If you look at it, you can see that it is oblong. It's not perfect. The end mill I was using was a little wore out, but it was the only 7/16 one I had. But we did get it done, and if you slide the pin in, you can see there's not a lot of movement up and down, there's hardly any. But if you slide it side to side, it will slide. So hopefully that'll work. Okay, got our TIG welder set up, just set at 125 amps. I've taken my bushing and I've put a mark on it so that I know where I want to tack it in relation to the slot. I'm gonna grab my hood and let's give it a try. Okay, so I've got the Porta-power handle on and assembled, and I've checked it for operation. I can see that the slot is in the right direction. I think what I'm gonna do is set this down, and then I'm gonna gently pull the pins out, if I can. Okay, so I've got it set where I want it to be. I'm just gonna try to get a tack on this side first. It's a terrible spot to try to tack it, but I think that's what I'm gonna do now. We'll see what happens. I'm gonna weld this up with 316 stainless TIG rod, since all of our parts are 316. Okay, so what we're doing is we're welding a little bit and then letting it cool, welding a little bit, letting it cool. So this is where we're at right now. We've got it. We've got a little section welded on either side. I've still got to do this side and this side. So I'm just letting it cool now. Once it's cool enough that I can touch it, then I'll probably do one side, then let it cool, then do the other side, let it cool. So that's where we're at. I gotta sharpen my tungsten real quick. Whenever you are TIG welding with DC, you always want to make sure that your tungsten's nice and sharp. That gives you a better weld. It's easier to make a good crisp start. So I'm just welding for a little bit, and I'm putting this wet rag on it, just a wet shop towel, cool it down. So we'll just give it another minute, and then we got one last little pass to do, and then it's welded out. Okay, we're done welding it up. It's nice and cool. So all that's left now is to reassemble it and see how she works. Okay, first pin's in. Okay, second one's in. Let's see how she operates. Okay, there's a little bit of a rough spot. I might have to file it down just a little bit, right in the middle. Okay, first pin's in. Oh, that's freaking money. And you can see if I go all the way up, there's only, it's less than a quarter of slop there. And that's between the bushing, the pin, and the handle. I'm pretty happy with that. It's nice and smooth. We don't have a rough spot anymore. It's nice and tight. We're using the full stroke. You can see we're getting the full stroke now. So as soon as I start lifting, I'm using the stroke of the piston. Okay, let's get these snap rings on, and I think we'll give it one more test after it's complete. Oh yeah, I'm digging it. I'm digging it. Okay, so I'll give you a little tour, little trip to Porta-power land. Okay, so I close my valve here, and if you watch the gauge, you'll see it build pressure. There she goes. She's building. So that's up to 5,000 psi right there, and I haven't really gave her the onion. So, and then when you open the valve, you lose pressure. Yeah, I'm pretty happy. That's turned out well. Now all I need is give me some rams and a hose, and we'll be ramming some stuff. We'll be ramming, Porta-powering. Team Porta-power. Okay, I think that's gonna wrap this one up. It was a pretty fun project. I like projects where you get to do a little bit of everything, little machining, little welding, especially when it's TIG. I really enjoy TIG. You know, there's a lot that goes into a little project like this, so that kind of makes it fun. And I like taking something that's been used and abused and making it better. And so I think that's pretty much going to wrap this one up. Thanks for watching, and we'll see you next time.